Yeah, yeah. Okay, you good now? Okay, cool. Hey everybody, this is Hunter Hardman. This is Adventures in Red Development. Sorry, apparently I learned how to use a microphone. So who am I? I'm a security consultant at Mandiant, former Blue Teamer turned Red. I live in Denver, Colorado right now, and like Tyrion Lannister, I like to drink, and I also know a little bit about things. So talk agenda, I'm going to briefly talk a little bit about introduction to rats, what is a rat, then I'm going to go into talking about what functionality a rat should have, as well as why you would want to write your own, and then talk about a little bit about security best practices when it comes to writing rats, and then my adventure, and then lastly a demo. So introduction to rats. What is a rat? Essentially a remote access tool, or commonly called a remote access Trojan. Essentially is just going to provide complete control over a system. So some popular rats that have already been written, Meterpreter obviously, PowerShell Empire, Cobalt Strike, specifically the beacon functionality of Cobalt Strike. There's other ones like Throwback and stuff like that. So if you've never used Meterpreter, you should. Well, you shouldn't anymore, but yeah. Besides the point. That's a little bit about it. This is PowerShell Empire. I really like that a lot. And then Cobalt Strike. So as far as necessary rat functionality, these are just the bare basic. There's a lot of other functionality you can include, such as like screenshots, key logging, but I haven't had the time to implement those yet. So command execution, file upload, file download, and then in-memory execution, because touching the disk is bad. So as far as command execution, how you can do that. So essentially what we want to do is execute a command and save the standard output and or standard error streams. In Python, you can do this a couple of ways. You can do the subprocess popen function. C++, they have the same popen, and then the wide popen function. And then PowerShell in C#, you can use the process class, which allows you to create processes with hidden windows and whatnot. So really nice functionality. As far as file upload, so this is going to be uploading a file to an implanted system. First thing what you're going to want to do is probably upload it to the web server. That way the implant can access it. And then the implant is going to beacon out, determine if it has any tasks, and then it's going to determine that it needs to download an uploaded file, and it will pull it down from the web server, which can be done in a couple of ways, URL lib2 or the request library in Python. C++ has the WinAPI URL downloaded file function, and then PowerShell has the web client download file function, as well as invoke web request. And then obviously after it pulls down that file, you're going to want to delete that from the web server, because having files on the web server unnecessarily is bad. Yeah. Now we're going to go on to file download, specifically downloading a file from an implanted system. So if you want to pull down somebody's C Windows boot.ini, you could. I found the best way that I do this is just with a multi-part form data post request, which allows you to set boundaries, and it also allows you to send binary data without having to do any modification or mucking around. So what I do first is I would probably split the file, and then you send the file in several chunks, because nothing gives the SOC a better lead than all of a sudden seeing a huge host of like 100 meg file, depending on if you're having an archive or whatnot. So I would split those up into probably around 1 or 2 meg chunks, and then host those each to the server at the specified beacon intervals, and then reassemble those back on the back end. And then once those are reassembled, you're going to want to move that out of the web server and move that to more like a home directory or whatnot. As far as in-memory execution, I'm not trying to reinvent the wheel. PowerSploit's invoke reflective key injection works amazing for DLLs and executables. And then if you want to do like a PowerShell process, I'd probably just do an IEX invoke expression, and then like a web client or invoke web request. So why would you want to write your own? Antivirus evasion. I don't like being caught up. I don't like MACD writing signatures for my stuff and catching me on it hasn't happened, but as well as a learning experience. I learned a lot of different languages. I learned like web programming languages as well as client-side programming languages throughout this whole process. Main cost, commercial rats can be expensive. Disclaimer that I am very frugal, so expensive for your company is probably not the same thing as expensive versus me. So rat security best practices. First off, server side, I would never store files in the web root permanently. I would harden a server exactly how I would like a web server. So I'm going to disable directory indexing via HTTP access or Mosquito or something like that. I'm going to prevent information disclosure via the server header. I don't want to leak what version of Apache I'm running, as well as mod security, which I mentioned above. Lastly, encrypting all post data regardless if it's being sent over HTTPS, just because of the fact that Blue Coat has that HTTPS inspection, and yeah. As far as rat security practices for the client side, I don't want to touch disk, just because it leaves behind forensic artifacts, which the SOC and forensic investigators can use against you to write signatures for your rat. And then as far as like never hard coding credentials, so never hard code database credentials or anything like that into the implant itself, just because of the fact that somebody can reverse engineer that, and that's going to be a bad day. As well as, lastly, I beacon interval jitter. So what that is instead of beaconing every 10 seconds, you beacon 10 seconds, maybe 13 seconds the next time, and so on. That way no one is like, okay, this is weird. I see requests every 10 seconds to this specific PHP page or ASP page. So a little bit about my adventure. Initial interest, I started when I was doing weekly kill trainings for a popular retail store. They would write signatures on our rat, and I wanted to be able to customize and change on the fly, and without very little downtime. So as far as deciding on a language, everyone's going to go through that. Deciding on a client language, server doesn't really matter too much. I like to use PHP, but I looked into C#, C++, Python, as well as PowerShell. C#. Pros, obviously, it's very easy to code in. It's a very high-level language. Cons, tools exist to easily disassemble it. So ilspy.p. And then also, you need .NET framework to be installed on the system. This is usually not an issue within corporate environments, but I don't like taking chances. As far as C++, it's awesome. It requires more resources to reverse. And creating statically linked executables is also awesome. But cons, it's not as easy, at least for me. I'm not really a programmer by nature, so it was a little bit harder for certain things, especially with dealing with like UTF. And then Python. Pros, super easy to code in. Cons, you're going to require some type of Python interpreter on the system that you're infecting, or you're going to require a third-party tool, which is like PyExe, to create an executable out of that Python. All right, so this is where I decided on PowerShell. So pros, in-memory execution, via IEX and web client, and invoke Robocrust, either of those. And I haven't seen this yet, but I've heard about it. PowerShell, the executable could be blocked by the client, like a company. So that's just one thing to think about. All right, so evolution of my implant. Originally I started this off as a proof of concept in Python just to determine if I could actually do this. And then I eventually migrated my code over from Python to C#, C#, C++, and then a couple weeks ago when Linux PowerShell was announced, I quickly started trying to convert my code over from C++ to PowerShell. All right, so this is the rat that I came up with CrunchRat. Don't ask me how I came up with that name. I don't even remember. But it's HTTPS rat. It uses self-signed by default, but you could easily have this use a real certificate if you really wanted to. If you are using the self-signed certificate, I would highly recommend you fill out that information, because if you don't, it's going to get triggered by Snort on dummy self-signed certificates. So don't get caught like that. That's a really silly way to get caught. As far as features, right now I have command execution, I have file download, file upload, and then as far as I'm the only one writing this, so I haven't had the time to code in like the ability to take screenshots or key logging or process injection, things of that nature. Database setup. So how are you going to track everything? That was the first thing that I was trying to figure out. How are you going to track beaconing hosts? Are you going to track tasks? And I came up with a solution to just database everything. So I created one rat database that encompasses everything. So the host table, which is going to track everything on the beaconing, like all the beaconing systems at one point. So as well as tasks. So tasks, everything, every task that has not been executed at this point. And then users, so rat users, so there's a login portal that I created on the web end, and that is what is querying. And then the output. Output is everything that has been tasked at one point and the output, like links to access that output. So here's the first one, which is the host table. So as you can see, I keep track of things like host name, date, OS, architecture, how fast it's going to be beaconing back to the C2 server, and then certain things like process ID and process file name for when I actually eventually start implementing process injection. Tasks, very simple. I have task ID, which I'll talk about in the next slide. User, who tasked it, the host name for which it was tasked, and then what the action was and what the secondary was. Again, I'm going to talk about ID, action, and secondary here in the next couple of minutes. So, lastly, here's the users, just username and password. I don't do anything really crazy with like salting, or I know it's probably pretty terrible, but I'm not a database admin or anything like that. And then the output. So ID, user, hostname, action, secondary, and then the output, which is going to contain a link, which actually links to like command output and stuff like that. And then the status. So that's just a simple yes or no. Has this been executed yet? So tasking overview. So I had just created essentially just a series of beacons and updates. So you system beacons out. Does it have anything tasked? Okay, no. Beacons again. Does it have anything? Yes, it does. Okay, and then it executes whatever the task is, and then it updates. So task ID is the ID, just a numerical sequential number that is used to identify the task. The action is I just chose like a single word, so single word action to describe the task. So for command execution, I just put command download, file upload. And then secondary. Secondary is going to support the task action. So if it was a command, it's going to be like a netstat an or who am I or hostname. And then if it's upload or download, it's going to be the file. So this is just an example of a beacon request. As you can see, every time it beacons, I just keep this information, and then based off that information, it determines if something actually is tasked. So in this case, there's a task 1. It's command to execute, and it's just a netstat an. I used HTML tags that actually weren't HTML tags to kind of parse out the fields, the actions, the ID, and the secondary. So implant configuration. I wanted it as customizable as possible. So C2 IP address, user agent. So every time the beacon updates or beacons, that's the user agent that it's going to be using. As far as beacon interval, and then beacon file and update file, which please change those because default they're just beacon.php and update.php. So as far as in-memory execution, as I mentioned earlier, touching the disk is bad just because of the forensic artifacts left behind by touching the disk. So I ended up just using PowerShell with the IEX and then a web client, or you could use the invoke web request function to execute in memory. So this is a simple command execution beacon request. So it's the same beacon that I showed you earlier because they're all the same. All the beacons are all going to have the same information. And then the response is to execute the who am I command. So what that'll do is it'll execute the who am I command, and then it'll fill out the output parameter with that output, and then the update.php function file, will parse that out and say that's a database. As far as a file download, so as I mentioned earlier, same beacon request. When it and then there's the file that it actually wants to download from the remote system. So it's a burp suite. And then this is where I use the multi-part form request. Sorry if it, oh gosh, that's all right, I wonder. But essentially it's just delimited. I have like a meg of, burp suite is like 12 meg or something like that. I broke it up into like, that's like a 1 meg chunk, and it's an excerpt obviously. Again, nothing new here with the beacon request. And the beacon response is the file on the web server that we need to download and save to the implanted system. So as you can see, there's a test3.exe that I need to save from the web server onto the implanted system. And that's just an example update request after it's already downloaded. So it'll download it and then it'll send a request saying, okay, cool, I downloaded it, here's updated, update the status, let them know that it's on the system now. And then, sorry, I kind of went through that a little bit fast. As far as demo, I'm going to explain a little bit of the demo environment, so I have a Windows 10 system, which is the .144. This is the system that we're going to implant. And then there's a C2 server, which is a Debian, and it's at the 140 address. So let's see. Okay, cool. Everyone can see that. So this is just the main login page. Default credentials are admin change me. So I'm just going to log in. And then here at the home screen, this is where I'm planning to implement a chat window where every route user can communicate and just coordinate activities, but I haven't gotten there yet. Hosts, as you can see right now, it's tracking everything that I talked about. There's no implanted systems right now, so that's all empty. The view output tab, that is, go back. Okay, view output, that is going to be where everything, that's going to be pretty much your bread and butter. You're going to see everything that's been that task, the output of that said task commands, and then generate payload. So this is going to generate a PowerShell one-liner. I haven't implemented base 64 encoding on it, sorry. But what it'll do is you specify the IP address that you want to call back to, as well as the implant file name. Sorry. This is just going through a little bit of the functionality. As far as add users, change password. So we're actually going to generate the payload now. So there's the server, the 140, and then I called my implant file m.ps1. So just letting you know that so like I said, I was going to change that. That PowerShell command will be base64 encoded here pretty soon. I just didn't get around to it. So I paste, so I paste that in there. It executes. You can see that PowerShell is the process running. You don't see it, but. And then now if I go over the host tabs, I see that I have this host beaconing back. So I'm going to task a command. And then you can task multiple commands for the same system. It's just the fact that only one system's in there. And that's the last command. I'm just going to ping, actually not Google because I didn't have internet access at the point. Just ping that 192.168.1.1. So here's the output tab. As you can see, 2 commands already executed, indicated by the output hyperlink, as well as the executed is now a yes. So I just refresh this. And eventually that gets executed. And as far as seeing the output, you just click the link, which will just bring you to a different page. And then, yeah, the only thing I can think about right now is my SQL has a limitation of 535 characters. So you have to keep that in mind. I have an error check, but just keep that in mind when you're executing commands. As far as here I am just telling you pretty much to change your password as soon as you get logged in initially. So that's the demo. I went through pretty quickly. I wanted to leave enough time for questions, so does anyone have any questions or whatnot? Actually, shoot, sorry. I lied. I have a thanks slide. Okay. So thanks. People I work with are really smart, as well as people I don't work are really smart, specifically PowerShell Empire, Armjoy, Enigma, Rafi, Colt Strike, Stephen Fuhrer, who came up with reflective DLL research, Joe Biolek, and then Matt Graber, who I believe is here. So that's. Oh yeah, here's my contact information. I'm on Twitter. I don't really post that much. Keep in mind though, my master branch is out of date. I still need to update that from the devs, so don't pull that down right now. But yeah, that's it on my end. Is there any questions or? Yeah. Oh, I haven't done that. When I was doing C++, I was calling a lot of the WinAPI stuff, but then I got a little frustrated. Not frustrated, but I just kind of was like, this. It's so much easier just to do in PowerShell. Any?
How are you doing CLS for practice, especially certificate checks?
Oh no, I mean I'm mainly just using self-sign as self-certificates, just because they're like I mentioned earlier, you can, if you wanted to register your own like certificate, you could easily, and
so if you were so the current implementation, the client's not really checking the service.
Oh, so okay, so in PowerShell, there's I believe it's the service point manager. You can actually tell it to ignore any SSL self-signed like errors. So it'll still use HTTPS, but it'll ignore those errors because it knows. So it's just I think 2 lines of code. Actually, it was just 1 line. Yep.
How can you talk a little bit how you manipulated Jitter?
So Jitter right now is not, I didn't actually get it fully implemented, but it shouldn't be that hard. You take the beacon interval, you either do some, yeah, you do like a rand of between maybe like 0.75 and 1, and then add that number to the beacon, to the interval, sorry. Any more questions? All right, cool. Thanks, everybody. I really appreciate it.